fall back into the low steady state. Those of you otherwise who had more, they will go to the high steady state, and that will be the prediction. But now you have a chance of trading among yourself. You can do it bilaterally. I can ask Aki that can I have a bit more, okay? Or we can do it multilaterally. Somebody could just say, look, I'm going to do the coordination, and we'll call that person a lender, yeah? Who will take the surplus capital of those who have, whose positional capital is higher than the steady state, and give it to those who are the deficit people. So that's what the market should be doing. Yeah? What's interesting is for the poverty trap story, or to stick, and poverty trap is sort of equated with the low level steady state. You also need, there's an implicit assumption of capital markets not working or being absent or imperfect in some form. Why? Think about it. Let's go back to the diagram. Okay, these two diagrams. Yeah? In the solar world, yeah, suppose we introduce capital markets. Yeah, what will happen? Well, what will happen is effectively the capital market will linearize the transition equation, because you no longer are bound by the slope of your production function. You effectively can trade at interest R, which is determined by overall availability of capital, and you trade along that line. Okay? Intuitively, what difference it will make? Suppose we do a thought experiment that in one country consisting of these small islands, there is no capital market, and an identical country, okay, where you have the small islands, everybody is identical, but there is essentially a capital market. The answer in this sort of solar world is easy. Nothing will happen in terms of the long-term steady state, because the long-term steady state is determined by fundamentals. But does that mean nothing of economic consequence will happen? Of course it will happen. People will convert faster. Because earlier, I had to save up to go up to the hill. Now, I can borrow, and essentially my transition to my own steady state will be faster. I can give you a very everyday example of it. You can buy a laptop by saving up. Every month, you put some few thousand rupees in a pot, and then eventually, say after 10 months, you can buy a laptop. Yeah? Alternatively, you can borrow and buy the laptop and start using it right away, and then you pay off the debt incurred so far. In equilibrium, after 10 months, you have the same laptop. The story is just the same. What happened? Under the capital market story, you just got there faster. Yeah? So that's what capital markets do in a kind of standard solo or neoclassical growth model. But now let's try to run in our head what would happen in this world, depending on whether you have capital markets or you don't have capital markets. Okay? So now it's interesting. Think about it. Suppose initially you are stuck in this low steady state. Yeah? It's very clear which is the more productive steady state. Clearly the higher one, right? Now with capital markets, effectively, once again, you'll have a linearized transition equation. And effectively, if I add a straight line, you can go and climb up that transition equation and go to the high steady state. You're no longer bound by your initial capital stock. Again, what I'm saying translated in everyday terms is very simple. That if you truly have the productivity, all you're missing is the capital. There is gains from trade. Some lender should spot the opportunity that if I give you this and you pay me back whatever is the rightful return, you gain, I get my money back. If anything, I get higher than standard market returns, and you get to climb up and reach your full productive potential. So therefore, for this kind of a poverty trap story to stick, you need some imperfection in the markets too. Because otherwise, you will just, whether a formal credit market exists, or people can informally pool. You can always say in a given village, if there's somebody who's has high potential and should go to the city and get educated, either a rich person in the village or villages collectively can raise the funds, and you can escape that kind of a problem. So you have to assume either everybody in the village is poor, or the institutions are not good enough, and therefore what will support this kind of a market exchange doesn't happen. And it is not a surprise that capital market imperfections receive so much attention, because any market can be imperfect. Market imperfection is a generic term, right? Why are capital markets particularly likely to be imperfect? Okay? The reason, of course, that is that for any transaction where there's a time separation between the act of essentially buying and paying back is more subject to opportunism than others. If I really try to buy an apple or a cup of tea from the shop, the only way I can avoid keeping my part of the bargain would be able to run, sprint very fast, take the good and run. Yeah? Whereas in the capital market, what is happening? Somebody is paying you money, real money. Yeah? And what you're paying back is a promise. And to the extent the promise is credible, good. But to the extent the promise is not credible or you have doubts as to whether the promise is credible, then it's not so good. And that's exactly why we need contracts, we need legal systems, we need debt recovery and all of that. Why? Because there's the time-separated nature. Okay, so this is basically my build-up to the core empirical test. I had a more leisurely introduction, but because we are already a bit late, I think that let me just carry on and present the core findings, but I'm happy to have some question and answer where I can try to relate that to more broader debates and any other questions you may have. Is that all right? Okay, so let's go straight to the empirical analysis. So what we do in this paper is essentially start with a framework like this, and then essentially my colleagues Oriana Bandier and Robin Burgess at LSE, they have this paper in QJ in 2017, which is a very interesting and important paper, and the culture at LSE and I'm sure many other places is to be plenty critical of each other, so therefore it's not empty praise, it is an important study. Why? Because it's one of the first randomized controlled trials where essentially on a large scale people were given random capital grants. So think about again that hypotheticals, you're all individuals, in an empirical setting, yeah? I'm randomizing and some say I take 2 columns of people and let's think of those as villages, yeah? I randomize that some villages, these 2 columns, they will all get a certain amount of capital transfer, others, nothing will happen. They'll say hi, they'll say stay well and will leave. Okay, that's what will happen. So then what the study does is they basically have essentially 4 rounds of resurveys where you're tracking what's going on. And that's where it gets powerful. Why? Because think about it, first of all, any mobility data is hard to really, if you look at across the world, there are some data sets, but to track any individual systematically over time, which is what you need to test poverty trap versus convergence, it is not easy. Yeah, often it's repeated cross-section, but then it's a problem, who are you comparing with whom? Yeah, that's the first thing. Number 2, even if you suppose you create a panel where I track the same set of people, say over a 10-year period, and I track whatever is going on with them, the trouble is, whatever is happening in their accumulation behavior is deterministic and endogenous. I have no explanation as to what caused the initial differences in the capital stock, and therefore I don't know whether I'm picking up the effect of parameters, if I'm picking up the effect of the kind of mechanisms I have in there, right? So therefore I cannot ideally test for the convergence type of world with a poverty tracking world. What would solve it? If I could engineer the shocks randomly, because then whatever is the initial K0, I randomly give some people, and by random I mean the fact that if you have, say, delta is the extra capital, that's orthogonal to your initial K0. So statistically speaking, that's the sense in which it's a random. Because if it so happens that those who had a bit more capital also were the ones that got more extra capital, then we are not testing these theories again. Yeah? So one of the things about this study, and I'll tell you what they do briefly and where we take off, which I will want to focus on the remaining part of my talk. What they did was basically they worked with this huge NGO in Bangladesh called BRAC, okay, where they had this what they call the ultra poor, which are the poor that don't even qualify for or are not interested in microcredit. That's why the category came up, because BRAC like Grameen was initially just a microcredit organization, but in the process of doing it, they realized the very poor are actually afraid to take loans, or they just struggle with the loans. Okay, so therefore they decided that this is not going to work for the very poor. Okay, that's why they have what is called an ultra poor program. Okay. So what BRAC did in collaboration with these researchers, okay, is essentially randomized by village, and these are by the mission of BRAC. Essentially, it's a women-centered program. So all the recipients are rural women who typically work as day laborers, whether it's an agricultural laborer or domestic labor, okay, and in relatively poor part of Bangladesh, okay, where basically you give these people, you randomize the villages and you give some of them about 4,000 beneficiaries, essentially an asset transfer worth of $560 in 2007 purchasing power terms, okay? And then you surveyed them, they surveyed them again in 2007, 2009, 2011, and 2014, right? Now what that paper found, and this is where I'm kind of summarizing it, they were not interested in the dynamics, okay? That's where essentially our new study takes off. They were just interested to know what was the effect of it on average, okay? And one of the striking findings of this paper is the fact that initially there was the strong correlation between people who had a bit of capital versus those who didn't. Those who had a bit of capital invested in livestock, typically cows and goats or chicken, okay? And then those who did not have anything, they were basically doing day labor jobs. Yet the livestock returns were higher. So this is a classic situation if you think about in terms of a theory. There are two technologies. You can either work as a laborer, yeah, and then you get this flat amount, or you can accumulate up your livestock assets and get a higher return. And then you want to ask that if the gaps are there, why aren't people getting into livestock farming? So presumably, and indeed in the survey confirms, the capital, these people are not credit worthy, so they could not borrow. So there was something that must have been preventing their accumulation behavior, so they were staying at low capital rates. So now, what happened in this particular intervention is they randomized this allocation of extra capital. Now, this $560 per PPP in 2007, especially with exchange rate fluctuating so much, it may not be so easy to wrap your head around what that means. So my co-authors come up with a very simple thing. It roughly means one cow and a bit more in Bangladesh Taka at that time when the survey was done. That's how we should interpret it in real terms, roughly speaking, right? Not everybody got a cow. Some people got something else, okay, a swing machine or something. But roughly speaking, that's the sum that we're talking about, okay? So it's like one cow and a bit more, okay? So not exactly just that cow. What they found is those who got it and who were doing day labor before, they all switched to at least part-time self-employment, and some of them eventually full-time self-employment, which is this livestock business, okay? Their incomes, consumption levels all went up, and this is really the striking finding, and I'm skipping things quite a bit because I want to get to the, this is very interesting. Their saving rates went up quite a bit. If you look at the saving rates, essentially that's a 400% increase. 400 means 400%. That's roughly means 4 times. Yeah. Now you have to remember though, these were low levels anyway. So if you have a saving of 100 rupees in the bank and then after all this intervention you have 400 rupees, yeah, in absolute terms it's not that much. So therefore we should not think that these are if all the if there is ever anywhere return the kind of chit funds offer, that's where to go. The whole world will line up, all the Sharada people and others, and go to northern Bangladesh to earn these kind of explosive returns there. But that's not the case here. We're really talking about low levels of capital, okay, and then you have this kind of boost. Where we start off is basically in the following, so in the current data. So using their estimates, they found that the average rate of return is about 22%, which is much higher than the prevailing interest rates, right? So therefore, clearly, if these people could borrow, they would borrow, but something is not happening. This diagram is the start of our current exercise. If you look at this diagram, and I'm sorry that it's not as vivid as it should be, basically that black curve, okay, this one, is the initial PDF of long productive assets. What we have in the horizontal axis is productive assets in their financial terms, yeah, converted to long. That's what we have. That's why 2, 4, etc. And that's why 0 is not, it gets truncates off to something which is a bit higher. And when you have basically nothing, it's normalized to 1, and log of 1 is 0. Okay, so that's the distribution. If you look at this curve, the green one, this is right after what's happening after the intervention, when people got this curve, right? And this is basically the beneficiary zone. Yeah. So clearly, a bunch of them now. There's a little bump here in the probability density, and you have that. Our paper's origin came from staring at this diagram and brainstorming. If you look at year 4, which is this curve, and this is final one is year 7. Yeah? You're beginning to see some divergence. So initially, you had pretty much most people concentrated in the left part of the density. Most people didn't have something. Some people had, little bits of stuff, right? So that's why that's the kind of density you have. Then you have this injection. Okay, so a number of people, you have the kind of fat tummy part of the curve, right? Yeah, and of course, those who had a bit more, they went up a bit more, etc. But after that, some people seem to be moving. If you could do a movie version of it, yeah, some people are moving away to higher levels, and others are falling back to the original levels. And that was essentially the origin of our thinking. That if we look at the dynamics of this. Is there evidence for poverty traps? Why? Because this is where it's very theoretically, as well as just from the point of view of economic applied economics, the testable predictions of these two models. If we look at just the difference in the capital stock, yeah, as a function of the injection and whatever your initial capital was, these two models give you different prediction. So if you actually have an empirical setting where you have this kind of accumulation behavior, so you can actually measure what is happening to subsequent capital stocks or increments or the changes, you should be able to distinguish between these two theories. Okay, that was that was our game really. That was what we were trying to chase. So let me go to. I'll skip this and come straight to this. So let's think about. Now connecting the theoretical framework that I have laid out to this empirical setting that I have verbally described. So assume everybody has the same productivity parameter A, and everybody has a given K0, which can differ from people to people. Now, the beneficiaries all get the same transfer. That's the interesting thing. Yeah? Then the transition equation will be K1. This is exactly, I've rewritten that transition equation, but I've not made any comments about the F, because F is allowed to be either the classical production function or this S shape or any other non-convexity. This is just a mathematical statement that this period's capital stock maps into next period's capital stock subject to this shock. And what we're interested in this delta 1, which is what is your next period's capital stock, and that can be estimated using, from data from several periods. We focus mainly on one, but we have done that for all the other periods as well. Is how much do you go up above the level compared to K0 plus delta? Now, I've told you a fair bit of theory. I've given you a bit of a breezy introduction to an empirics, but I would request you to reflect for a second, really play in your head the question. That suppose we now exactly do this experiment in the two theoretical worlds that we talked about. What would we expect? So let's first think of the solar world or the convergence world. Yeah. So you have people distributed according to some K0, and that could vary. Yeah? And then you're giving people a bit of a delta, and everybody is getting the delta. Yeah. What would happen in this world? Think about, just to give you. Get your sort of brain anchored in the right place in this diagram. Suppose you had exactly K star minus delta before. Namely, your initial capital stock just was delta short of the steady state. What will happen to you? Well, nothing, because you're going to get the delta and you're going to stay there. Yeah? So after that, essentially your next period's capital stock, if you do the increment, nothing will change. But now comes the interesting bit. Suppose you had more. You have more than K star, and you get the delta. What will you observe? You will observe decumulation. These people will shed the extra capital and go to the original K star. And suppose you were less than K star. What will you expect? Well, you should speed up. Your next period's capital stock should increase. The delta K that we want to empirically measure, that should be positive, okay? And if you do it for several periods, it should be shrinking in this world, okay? So there is a prediction on that too, yeah? And you go to the steady state. So that was relatively easy, okay? because it was relatively easy, I'm not going to go through the diagram where it's described. So this is the diagram that is described. Okay, and I'll make the slides available, so if you want to later stare at it and get a better sort of detailed view of it, you can access it. Okay, so here all I've done is that orangish brown thing, that's the delta on the horizontal axis, and the green thing is the movement of the capital stock in the next period, and this is the geometric counterpart of what I told you verbally, right? That if you start with a high level of capital and you get the increment, you have a negative, here you have a positive. Okay? And what's neat here is exactly a curve like this, because now I'm plotting the delta 1 on the vertical axis and the K0 on the horizontal axis, and roughly speaking, those with high K0, they will show a negative sort of, incremental capital, it will go back to 0, and those with low K0, except for very, very low levels of K0 where the curve would typically be upward rising, because at that point, you're in that wearing the bouncy shoe part of the accumulation process, you'll typically go down. Does this thing remind you of something you've learned in macro, a typical macro regression term? This is reversion to the mean. This is exactly the mean reversion pattern. Namely, those who have more, they tend to shrink. Those who have less, they tend to kind of go up. So therefore, this is an empirical application in a micro setting, okay, microservice setting, of the mean reversion principle. That they are all going to some steady state. Therefore, those who have more will be shedding, and those who have less will be gaining, and therefore you have the deltas will have this negative relationship. Now let's do the same thing with this alternative work. Okay? Before I do anything else, so therefore let me not show it, let's sort of get in our sort of head as to what should we expect. Now you know there's a bit of a twist to the plot. Why? Because if you start with a low-level stable steady state, there, if by chance your delta plus K0 exceeds the K hat, then you're king, because you exactly have crossed the hump, and then you will just go up to the high steady state. But if just by bad luck, your extra K0 plus delta falls short of that K hat, is the class saying, so near yet so far. You climb up a bit and then you slide back to the low level. So this, in a way, indeed, if we do this, okay, so that's what this diagram kind of explains. Essentially, there will be an added nonlinearity compared to what we had for the solo work. Now, if you, depending on whether you're very low or middle or high, the pattern will be different. How different? This one. This is the same curve, the delta 1 on the vertical axis, and K0 on the horizontal axis. And essentially, I worked out what the theory model explains or predicts in terms of what should be the relationship between delta 1, okay, and in your initial capital stock. And this is what it's saying, that if initial capital stock is very low, then having a little of delta doesn't help you. You will eventually just decumulate and go back to your original low-level steady state. And if your original capital stock was very high, say here, then having that, you display the same mean reversion property that you would see in the solo model. Action happens around here. This is where the action is interesting. Why? Because that's where those who just cross that, they will accelerate up, and those who are just falling below, they will go down. So that really is what we are taking from the core theoretical models in terms of the empirical prediction. Now I want to present the core empirical evidence, and then I'm happy to go on talking, or depending on the time constraints, switch to the question answer and iteration. So basically, this is what we do, and I've already shown you this diagram where we have some heterogeneity in the original distribution of K0. And just to sum up, what our theory has told us is a prediction of how delta 1 would be. Delta 1 is your capital stock increment in the next period, like day after tomorrow as opposed to tomorrow. That delta, how that depends on your initial capital stock. And these two models are giving you different predictions in terms of how the curvature of this behavior should be. That's what we learned from that theoretical exercise. Okay. So let's look at the diagram. So this is basically a non-parametric estimation of the transition equation. And remember, in the vertical axis, it's not yet delta 1, it's k1. So I'm first doing, and I'll show you the delta 1 too, but we are now literally non-parametrically estimating the transition equation first, and then, of course, in the next diagram, the delta, change in productive assets, 2007 to 2011, okay, as a function of the initial log capital stock, okay, productive assets measured in log terms. Let's stare at this a bit, yeah. So this, I have to say, every time I look at it, and this is even today, I get a little flutter of excitement, because this is very interesting. First of all, it's an empirical estimation of a transition equation. We are not the first to propose it, but we are the first to do it with randomized control data. So therefore, the usual problem people have in identifying out of this is the fact that your shocks could be correlated with your productivity, your initial capital stock, and that messes up the standard interpretation of the diagrams. This is the classic thing. Countries that save more have high GDP per capita. What does it tell me? Does it mean savings causes GDP per capita, or does it tell me that GDP per capita causes saving, right? It could be reverse causality, or it could be some third factor related variable that's driving all of that. Here, by construction, we have done this capital injection in a randomized way. Yeah? Now, if you look at it, well, and we really didn't do much with this data because it's 4,000 sample and it's sort of all very straightforward. So we are not doing anything very high tech here. You have a transition equation that remarkably looks like the one that's associated with the poverty trap world. Yeah, you can see that you have this kind of a thing, and if you measure the threshold point there, 2.34, that's the log unit, and we have done it parametrically too. You can do a cubic polynomial, and you can allow for further, curvatures into this thing. After that, you have that bit that kind of goes up to what seems like a steady state around 2.8. Okay. Now let's look at the other one. Yeah. If you look at this diagram. Yeah. Again, if I was high-tech enough, I would juxtapose this with this theory diagram. Because that is what the empirical counterpart should be. It should be either this or the one that I showed earlier, along with, which was the implication of the Solow model. So essentially, we have the following, that you have exactly that prediction that around that 2.24 or 2.3, depending on what estimation we're using, we have this delta K thing positive, and then it dampens, because this is where eventually the Solow type of thing kicks in, that if you already had too much capital, then that extra capital would just accumulate and fall here. Whereas here, this is the kind of almost tragic part of the story, where initially these people have a cow or whatever. Because they don't have complementary assets, their K0 was low, this K0 plus the delta is just not enough to get to that K hat. Imagine, and it's not one interesting thing about the survey, for which I can't claim credit, we are just applying that to the theory, that's where I'm involved. But what's the neat thing about the survey is it's something, especially in an audience like this, because it's rural Bangladesh, which is similar to rural West Bengal, right, in certain ways, you can exactly see what is going on. Suppose a very poor person is given a cow. Yeah, of course, if you or I are given a cow, that would be a disaster too, because we simply don't have the expertise or the environment to deal with it. But on a serious note though, if you give somebody an asset, that person needs to have some minimum complementary asset to make good use of it. Otherwise, the person will fumble around a bit, right? And eventually either decumulate it, realize this is not really my thing, I have to go back to doing my day labor thing. I just had a temporary boost in income, and then it sort of falls back to the normal level. Okay, so that's exactly what we are finding, and this we are obviously very excited about. And this is the parametric identification of this, where we fit a polynomial of degree 3 to this particular with this particular data. So that's, in some ways, if I summarize what our current research paper, the paper should be available in a month or so. We are almost there. The slides are already, they're already publicly available, and I'll make this version available. Essentially, what we have is a kind of core of this paper, which is we have these theoretical predictions in terms of how these two different economic models imply in terms of what capital accumulation behavior should be, in a world where there are random capital injection, and the empirical counterpart, where the random capital injection is orthogonal by design to the characteristics of the recipients, which makes it econometrically respectable. Because otherwise, if you just say, oh, I saw her buying a cow and this is what is happening to her, well, buying a cow is endogenous. It's endogenous to 9 other things that could be going on, and therefore you cannot really causally say that having an extra cow or having extra, resources. Here you have engineered it, and that's really the attraction of our cities when they are feasible, and most of the time they're not feasible. Let's be realistic here. For most applications, how do you say do something like macro policy, or even forget macro policy, anything that involves a large scale, it is really hard to think of doing a randomized kind of design, right, because of the sheer logistics of it. But for a sort of level below, that's the power of a sort of method like this, that you're avoiding all the points of finding instrumental variables, or think of a natural shock, anything essentially that's your almost sad attempts at trying to introduce some randomness on the right hand side. Of course, the entire science of econometrics has come up with various methods of it, but we also know that it's never fully satisfactory, because there are always some bias or the other. So that's really what at the core of our contribution is. So given the time constraints, I am happy at this point to kind of get to the concluding part and then take questions, but I'll really look to the chair for instructions. That's my core finding. It's about 130 slides. There are many things I want to show you. Various alternative hypotheses, could it be a nutrition link, alternative stories of poverty traps, etc., etc. But this is our core finding, that there seems to be a production indivisibility coupled with capital market frictions, and indeed in this particular world, the evidence is, why do people stay poor? Well, because of absent capital markets and certain non-convexities in the production technologies. That would be the title. I do have some hopefully interesting policy comments to make too, but I will really leave it to the chair to instruct me.
No, I think you should make a concluding statement now and then invite questions.
Okay, sounds good. Okay, so as I said, that maybe you shouldn't even look, because I get a headache looking at slides moving so fast. But we did lots and lots of things. Okay, lots and lots of things. Okay, and lots of things. So basically, this was my summary slide. Okay, that beneficiaries who do not start with complementary inputs regress back to poverty despite the large transfers. Essentially, those who are elevated